So what are the 4 ways we can prove 2 triangles to be congruent?
Angle, side, angle, side, angle, side.
Yeah, angle, side, angle. Side, angle, side.
Angle, angle, side.
What are the 2 ways we talked about that don't work?
ASS.
It's SSA, Leo.
Oh, my bad.
Okay, what was the other one?
Angle.
Angle. Alright, yeah, those don't work. Okay, there's one more. This will be the last one. So, okay, the way that they do this today is we're talking about right triangles. You guys remember what the sides of a right triangle were called?
90 degrees.
The sides are called
Hypotenuse and legs.
hypotenuse and legs. The legs are around the right angle, and the hypotenuse is across from the right angle. It's always the biggest side. Hypotenuse. That's how you spell it.
That's not gonna help.
Hypotenuse. That should help. Alright, helps me. Okay, so sometimes on this they're like, if it's a right triangle, like leg is going to work, but I don't really want us to call it leg, because what did we learn that would work for this already? Side, angle, side. Okay, so the book was going to say leg, but I just want us to stick with side, angle, side. Okay, and there's some other ones. There's like leg angle works also. Like if we did leg angle, like these angles were the same. We know they're 90 already, but if we did leg angle, then it'd be basically be angle, side, angle, right? Or yeah, anyways. But there is one thing that works on a right triangle that doesn't work on any other triangle. And it's this one. I'm going to draw it first. Okay, what would this be called normally? Side, angle. Okay, that doesn't work usually, right? But on a right triangle, it does. But we don't call it side, angle. We call it hypotenuse, leg. Okay, so this is the one new thing, the last new thing actually for triangles. Hypotenuse, leg, or just HL, is going to work. Hypotenuse is across from the 90-degree angle. The leg is one of the other sides, obviously. And then if that happens on a right triangle, then it does. They are for your hypotenuse, leg. Great page. I think that was it, just the right triangle stuff, we just did it. So they gave us a bunch of theorems for right triangles, but most of them are repeats of like side, angle, side, and angle, side, angle. So just remember the hypotenuse, leg, you should be good. So on page 188, you guys ready to roll? It says, draw and mark a pair of triangles illustrating each congruence theorem. Then name the general triangle congruence postulate or theorem that could also be used to prove the triangle is congruent. If no such postulate or theorem exists, write none. Does that make any lick of sense to you guys?
Yes.
No.
Okay, number 1 says LL. What do you think LL stands for?
Leg.
Wait. So we need to draw 2 right triangles. And we need to, we'll put the little right angle in there. We need to show what, basically? The legs are congruent. So mark. Alright, we're not going to call it leg. We're going to call it, what's the normal? What's side, angle, side? So this is what they wanted. This is number 1. Okay. HL.
What is it called?
Hypotenuse leg. So hypotenuse, it doesn't really matter which leg you mark, just one of the legs. Hypotenuse leg. Okay, what's hypotenuse leg called in the other things?
HL.
No. Hypotenuse leg is HL. What's it called in other things? Side angle. But that wasn't one of them. So on this one we're supposed to put no. This is the hypotenuse leg is the only one that doesn't have a normal thing to go with it. Hypotenuse leg is the only new thing. I think 3 was the only hypotenuse leg. Yeah, I don't know where they would do it again. Number 5. Okay, 4 and 5. What do you think LA stands for? Leg angle. So in one case, on number 4, the leg and the angle should be right next to each other, adjacent. And then on number 5, the one we're doing, the leg and angle should be across from each other, opposite each other. So let me draw that in the picture, it'll probably make more sense. So let's say those two legs are the same. And then what angles would I mark the same if I want them to be opposite the leg? The top. So on number 4, they want the adjacent angle to be the same, so you would like mark these angles right here. Okay, anyway, what's congruent on, or by what method is these triangles congruent? Number 4 is going to be a little different. Yeah.
Where's the first sheet of that paper? I'm still looking at the second.
Okay, we're going to turn it in tomorrow.
Tomorrow?
Well, I guess we don't. That's okay. I'll drop it in the bucket.
What is opposite case? Oh, I'm not, never mind.
All right.
Was that Zoe?
Yeah, her name's Zoe. She's got 2 sisters, Montana and Willow.
I had a cat
Willow reminds me of a movie made in 1989 about a little dwarf guy. Yeah. Childhood memory. Okay, number 7. Which condition is valid for right triangles but does not work for other things? Side angle, yes.
Mr. Jordan, do you still remember like the first movie you ever saw in theaters?
That's not bad.
No.
I think I saw E.T. in theaters, but I think they replayed it like later for some reason. That might be the first one I remember. I'm not sure what the first thing I saw.
Mine was Angry Birds.
The first
No
movie
way.
you saw was Angry Birds?
Yeah.
No.
In theater?
Yeah,
Way.
like an old trashy theater.
Mine was Journey to Mysterious Island.
I don't
With
remember.
The Rock.
Why do you remember that?
Oh.
Because it was in 3D, and then I did
Plus we were
see
four
Then he
back
got to
then,
see
so I was
his
like,
muscles in
"Phew."
3D.
Now you're rolling the dough. Number 10 and number 9. Write a triangle congruence statement and name the right triangle congruence theorem that justifies it. Okay, we're not going to do the right triangle congruence statement unless it's a hypotenuse leg. We're still going to use side angle, side, all that stuff. All right, so they're telling us the triangles are congruent, so let's just start with the triangles are congruent. What order should I do in the letters? How about if I go, let's say QPR, that would be congruent to triangle what?
TSR.
TSR. times they're upside down from each other. All right. How do I know those two triangles are congruent? What is not marked in the picture, but I know has to be congruent? The vertical angles. So imagine there's a little red mark in the middle there on those two angles. So by what are those two triangles congruent?
Angle, side.
Yes, angle, side. So the book put hypotenuse angle. We're not going to do that. All right, number 11. This one's tricksy. You guys know what's congruent there that they didn't mark? Yes, the lines are parallel. So angle BCA is congruent to angle CAD because they're alternate interior angles. What else is congruent that they didn't mark? The AC is congruent to itself because it's a side in both triangles, right? Yeah, it's the hypotenuse. So, you guys see what we got? So, we got the right angle, we got that thing, right? And if, on this other one, same stuff. We got that one, same as that one. We got that one, we got that one. So, how do we know the triangles are congruent? Angle, side. Oh, I forgot to say statement though. Alright, triangle, okay, if I say, let's go, triangle ABC is congruent to triangle. If I go ABC, what would that be like on the other triangle? CDA. Angle, side. Voice is really low this morning. Number 13, what do we know is congruent in that picture that they didn't tell us? Vertical angle. So we got a little angle in the middle, so
Angle, side.
it's angle, side, angle. So let's, if I say triangle MNH, that would be congruent to triangle QPH. Q, angle, side, angle.
How many lines is the proof on 14 gonna have?
14 is not a proof.
I'm just on.
Explain why leg, why do we not know, why can't we use leg on number 14?
Cause you need an angle.
We don't know if they're.
Yeah, we don't know A and D are, if A and D are right angles. It looks like they are, but we don't really know. On number 15, okay, it's given that it's an isosceles triangle, PQR is, and that segment QS bisects the vertex of angle PQR. So it's bisecting an angle, not a segment. Okay, so in other words, QS is not cutting PR in half as far as we know, but it is cutting angle PQR in half. Because it says segment QS bisects vertex angle PQR. Okay, so we know the angle's being cut now. All right, number 1. Oh, and we're trying to prove that PSQ and RSQ are right angles. So basically, here's the plan. If we can show those two triangles are the same, then I know those two angles down there, PSQ and RSQ, would have to be the same because they're corresponding parts of congruent triangles, CPCT. And if they're the same, and they have to add up to 180, then what does each of them have to be? 90. That's not quite how they did it, but anyway, pretty close. Okay, number 1. Guess what we're going to put on line 1?
PQ, isosceles, PQR.
Triangle PQR is isosceles, and segment QS bisects vertex angle PQR. So just copy down the given stuff. Okay, we're going to play the game this way. If you answer a question, you are disqualified from answering the next one. One of those games. So, front row, you guys might leave off unless nobody answers it. Number 2, what do we know by the definition of isosceles? Yeah, Lydia. Yeah, they were kind of vague in that, like, how do we know it was those two angles that are the same? So, yeah, she said PQ is congruent to RQ. Those are QR. Those are segments, right? So put the segment symbol on top. Okay, the next line is a trickier one because they didn't give us a hint. All right. On the past 2 days, we've been doing isosceles triangle stuff. Right after we said this triangles are isosceles,
P is congruent to R, angle P.
angle P is congruent to angle R. Yeah, if we know the legs are the same in an isosceles triangle, we know the base angles are the same. What's the reason we can give for that, Trey? Do you know what that's called?
Base angles are equal on
You could say the
isosceles.
sentence that I said, like, if two sides of a triangle are the same, opposite angles are the same. But
Isosceles triangle theorem.
isosceles triangle theorem is the easier way of saying it. Okay, on line 4 it says definition of angle bisector. The part of the given was that QS bisects angle PQR. So what do we know if bisect means
Intersect.
cut into, you know what I'm saying?
Thanks. QS bisects PR and PSR.
Angle PQR. That was the given. And it doesn't bisect segment PR. Really? Say again. QP congruent to QR. Well, we already said that, but that was because it was an isosceles triangle. Abby?
Angle PQS is congruent to RQS.
Yeah. So if an angle is being cut in half, what do we know? Those two little angles that are created have to be the same, right? Bisect means you're cutting it directly in half. If an angle is being cut directly in half, we know that each of these angles is the same. We don't have to call them the angle PQR though, or PQS. What's an easier?
1, 2.
Yeah, you can just say angle 1 is congruent to angle 2. Alright, let's go back in time. Let's let's mark everything that we've said so far. So we said those angles are congruent. What else did we say is congruent?
The
Q and QR.
corner two angles.
Okay, so line 5, how do we know the triangles are congruent? If you answered one. Okay,
Split in half.
how do we know these two triangles are congruent? Angle, side angle. Okay, so they're using CPCT for line 6, which means corresponding parts of congruent triangles are congruent. And remember what we're trying to get to was say that PSQ and RSQ are right angles. So what do you think they're going to say next? Well, if we're trying to say that these two angles are right angles, if they're the same angle, they have to be right angles, right? Because 90, only 90 plus 90 would equal 180. So first we need to say that they are the same. Why do we know that they're the same? Because we know the triangles are the same. Because they're corresponding parts of congruent triangles. So it's these two angles down here we need to say are the same. So angle QSP is congruent to angle QSR, or PSQ is congruent to angle RSQ. It's in the proof statement, angle PSQ is congruent to angle RSQ. Okay, and then line 7 just goes in and says they're right angles. Anybody want to give a shot, Brayden? Yeah, that's exactly right. Congruent supplementary angles have to be right angles. So congruent supplementary angles are right angles. Dun, dun, dun. How hard is number 20? Trying to find it.
A little hard.
The book used 4 lines. Okay. Let's see. It's given that those are right angles down at the bottom. It's given that XW and ZW are congruent. And all we're doing is proving the triangles are congruent. I must have been looking at the wrong problem. 20. Oh. They did it a different way than I would have done it. Yeah, you can do that in 3 lines actually. Okay, give it a go. Yeah, the book did it in 4 lines, but there's an easier way. You can do it in 3 lines.